Hey guys, how's it going? Today we're going to talk a little bit about hydrostatic pressure. So for Wednesdays, we're going to be getting into sort of a different, more technical, non-residential home type of discussion as far as foundation, underpinning, and repair and stabilization and stuff. So we're going to be exploring the more technical aspects of like the piering systems and the building codes that apply to all of them. We'll be talking a lot about railroads, roadways, hillsides, liquefaction, etc., etc., etc. Today's going to be a little bit more of a brief video. I've got a lot of rearranging going on. Things should stabilize next week and it'll be good. But that's sort of what we're going to start doing on Wednesdays. So what I wanted to discuss for a brief video for us is hydrostatic pressure. Static pressure. Sorry, again, things are different. Hydrostatic pressure. So the best way to describe hydrostatic pressure is if you ever had like water on a dinner table or something, you had a cup that you sat on top of it, and sometimes the cup will like start sliding freely, right? But when you try to pick it up, there's this suction that happens and makes it more difficult to pick up off of the table, right? Now this is going to be a theme throughout all of the technical stuff we go through. Was when we start talking about water. I saw this great thing on LinkedIn the other day. Somebody was explaining the level of difficulty of like mathematics, and they had like your basic algebra, and then they had chemistry or whatever came in next, like physics or something, and then whatever came after that was like quantum physics in this theoretical realm, and then after that was sand. And I loved it. It was a good joke, actually. I feel like if you throw in there water, it's also a lot of fun, because water and sand, terrible. But things get really fun with water, right? So 85% of all the problems that you're going to run into, whether it's liquefaction or liquefiable soils or slope degradation or consolidation of fills or inflow and infiltration issues inside culverts and infrastructure and things like that, it's all water issues, right? Migrating fines and so on and so forth. So water is the big issue. You're going to notice that as a theme, so it makes sense to start talking a little bit about water, right? So hydrostatic pressure, once again, is like the water that sits in there in the ground, which could adversely affect, for what we've talked a lot about, is like leveling things up, right? If you have water directly underneath a slab, and that water is permeating up through a slab, it could be difficult to break the hydrostatic pressure and create to free that connection in order to lift the slab up. Same thing for homes. So essentially you have, this is going to be difficult. You've got home foundation, and we actually just ran into this in Laguna Niguel like 2 weeks ago. You had a home foundation, right? And this sits, maybe 12 inches under, but our guys were doing compaction grouting using HDPF, or a high density polyurethane foam, and they were shooting well over 1,000 pounds into trying to pick this thing up. It was down 4 inches? It was down 4 inches, right? And at 4 feet, though, we had water. The DI tubes that we were using came up very, very, very wet, right? And it had sort of a clayey soil for the general area. It's Laguna Niguel, and it had a hillside on the back. There's a bunch of issues, right? But it was at 4 foot, and we couldn't quite, and we were pumping or trying to lift or whatever. What was happening was this hydrostatic pressure, this water at 4 feet was sucking down your footing, right? And then anchoring it down. So we pumped, I think it was almost 1,700 pounds trying to pick this thing up 4 inches. We only got a ½ inch of lift. As we continued pumping, eventually they broke this connection, right? Once they severed the connection of the water to the footing, we were able to get the entire lift, and we used like 70 pounds afterward. It was a very successful lift once we were able to recognize what the problem was, and then we're using the high-density polyurethane, which the hydro-insensitive properties displaces water while compacting the soil underneath, so you wind up with a strong, stable matrix underneath while facilitating lift, dewatering underneath there, creating all the fun jazz. So the hydrostatic pressure is what was the issue there, right? Just like another job that we did up in UC Berkeley many, many years ago, we had a piering system, and we were using hydraulic push piers in order to level out this residential home. We loaded each pier along this entire wall at 4,500 PSI. That's 4,500 PSI of upward pressure pushing on the footing, and then the crews had left the piers loaded overnight, right? So they took off, and everyone was off site, and at 2 a.m, the hydrostatic pressure gave out. And when you have something that's anchoring down, it's like got that suction, right? And then you've got something pushing up at 4,500 psi, and then suddenly that thing that's holding down is just gone. It jolted the entire house like an earthquake, right? Jolted it as all of these piers pushed up at the same time, and the homeowner was freaked out, totally understandably. They're calling everyone, and I wound up getting the call at 2 a.m. as they're explaining to me the whole house shook and everything was really, really kind of scary for them. And, being able to explain that it was hydrostatic pressure and that was giving way and everything was fine. And sure enough, when the crews came back the next day, they reloaded all of the piers and the house came up uniformly and just, it was the easiest lift ever once that pressure was gone, right? So I talked about a couple of houses, and I talked about using HTPF or hydraulic push piers, and where we've ran into problems with that before. But you can think about the considerations that might come into play if you're talking about like drilling and dropping rebar for caissons or dropping helical piers. And you can also think about applications on where the water table sits with like swimming pools, right? Or commercial buildings, or underneath a bridge approach or abutment slab. Just hydrostatic pressure has the potential to be an issue, and this is why especially once we get out of this residential realm and we start talking about commercial, you start talking to people who have soils reports, and engineers have done the geotechnical investigation. You're able to profile the soil and figure out exactly what's going on under there. This is why things like moisture content and where the water table's at and all that jazz is very important to gather. So I think next Monday we're going to talk a little bit more about what I like to see before I give any estimates as far as technically wise. If an engineer goes out and does their geotech investigation, sort of some of the stuff that I'm looking at while I determine a foundation repair. But I mean, generally by then you have recommendations anyway, right? So that's it. Please, guys, if you have any questions, comments, concerns, drop a line below or message me directly. Please like, share, subscribe, and do all the other fun stuff like that. Again, I apologize. It's a shorter video. Things should start to stabilize for me next week. Stabilize. Got it. Thank you for your patience. Looking forward to doing more videos. Thanks.